Okay, so this brings us up to problem number 11, which is probably going to be the most complicated problem in this homework, in this guided practice that we're going to do. We've got parallel lines A and B, which are parallel to each other. I've sort of labeled the horizontal lines here A and B. And then we've got a set of three parallel lines, which are mutually parallel, C, D, and E, which are pointing in a different direction than A and B. And their intersection creates all kinds of angles, and we're only given the measures of two of them, 51 degrees here and 70 degrees here. We've got to find the measures of the remaining 12. So this is quite a puzzle, but we're going to find that it's doable, and we're going to succeed in getting all these measures. So again, rather than worrying about the order that the questions are given in, I'm going to take a look at this drawing and try to solve this in a way that makes the most sense so we get the easiest done first, and we can build upon these to get the harder and harder measures afterwards. So take a look at this. Notice that there are a couple of relationships that follow fairly quickly from the given angles. Okay, I can pick out several of them. Let me start with angle 2. Okay, the 51 degree, the angle 2, and the angle 70 make up 180 degrees, because the three of them added together make up a straight angle. So we can figure out the measure of angle 2 by using that relationship. So 51 plus the measure of angle 2 plus 70 all equal to 180. Combining like terms, we have the measure of angle 2 plus 121 equals 180. And by subtracting 121 from both sides, we get that the measure of angle 2 equals 59 degrees. Okay, so we now know that angle 2 is 59 degrees. I'm going to just pencil 59 degrees in there. We've solved that one. That wasn't too bad. Okay, is there any other easy one? Low-hanging fruit, we'll call it. Any other low-hanging fruit? Any other results that are pretty easy to see that we don't have to do much to get? Well, I see another one. I see that lines A and B are parallel and are cut by transversal E. And when they're cut by transversal E, I see that 70 degrees and angle 12 are same side interior angles, which means that they are supplementary. Okay, so angle 12 is supplementary to angle 70, which means that angle 12 is equal to, I don't really need an equation to do this, right? Angle 12 is equal to 110 degrees. That I can do in my head. Okay, good. Well, what's another one that starts to fall? Notice, it's sort of like falling like dominoes, right? The more we get, the more we can get. Now let's zoom in a little bit closer on the drawing and see what other relationships sort of pop up as we start to fill in the missing relationships. So angle number 12 is 110, and I say that gives us angle 4 and angle 11 right away. Because angles 4 and 12 are a linear pair, aren't they? So that means that angle 4 has to be 70 degrees. And so does angle 11, either by vertical angles or because it's a linear pair to angle 12. We've got two other measures very quickly. Looking very good now, right? Doing very, very well. We're getting lots and lots of angles very, very quickly. Well, now we have to think a bit. What are some other measures that we can come up with? Are there any alternate interior relationships with angle 51? Well, angle 51 is created by a transversal F crossing parallel lines A and B. Is there another angle created by angle A and angle F? Sure, angle 1, right? This angle over here. It is an alternate interior angle to angle 51. It's on opposite sides of F, but it's between the parallel lines. So it is also 51 degrees. We've got the measure of angle 1. Okay. What's another relationship that we can see? kind of concentrating to try to see if there's anything else we can come up with. I see another alternate interior relationship. This time I see it with angle 59. So angle 59 has two parallel lines, but its transversal would be F, right? F cuts parallel lines, and F cuts parallel line E as well as parallel line D. So F and E together make up the 59-degree angle, and F and D, which is the alternate interior angle to angle 59, is angle 3. So angle 3 and angle 2 are alternate interior angles, and therefore angle 3 is also 59 degrees. Okay? Well, does that make sense? Well, notice that angle 51 plus angle 59 adds up to what? These two angles together add up to 110 degrees. So these two angles taken as a whole are 110 degrees. Well, it so happens that this angle here and angle 12, which is 110 degrees also, happen to be corresponding angles, don't they? Okay, they have the transversal A, which cuts parallel lines D and E, and they're corresponding angles. They're both lower right angles, and they're equal. So far so good. It looks like we're making sense of this all. We still have some more angles to figure out. So let's look for relationships, either alternate interior, corresponding angles, or maybe even supplementary angles. Can we see any other relationships, or even linear pairs for that matter? Can we see any other relationships? Well, what about angle 4? Are there any relationships with angle 4? Well, we already know that it's alternate interior with angle 70. And that's assuming that we use the transversal E. But what if we say that A is the transversal? If we use a transversal of A, are there any relationships with angle 4? Well, if A is the transversal, then we must be using parallel line E and either C or D. So let's take a look. Are there any relationships between angle 4, transversal A, and parallel lines A and B? Well, 4 and 8 are corresponding angles. Okay, they're both to the lower left-hand side of the corresponding points. So angle A is 8 is also 70 degrees. Well, we could have figured that out, right? Because 51 plus 59 plus angle 8 has to equal 180. We would have gotten 70 degrees that way anyhow. Well, that just makes us feel more confident. So we were right all along that these two are corresponding angles. Okay, great. Well, finding out that angle 8 is 70 degrees helps us a lot. It gives us angle 7 and it gives us angle 6. How does it do that? Well, angle 8 and 6, these two angles, are same side interior angles. Because if the transversal is D coming down, cutting parallel lines A and B, then 8 and 9 are both interior. 8 and 6, are both interior angles on the same side. Right? So therefore, they're same side interior, and angle 6 is 110 degrees. It's supplementary to angle 8. Angle 9 and angle 6 are linear pairs. That makes angle 9 70 degrees. By the way, angles 8 and 9 are also corresponding angles. Can you see why? Now let's take a look at angles 8 and 7. So angles 8 and 7 here also have a relationship. They share the transversal A, this horizontal line, when A cuts both C and lines D. So they're both below A, they're both on the same side of the transversal, and they're interior to C and D, so they're same side interior angles. They are supplementary, therefore, and angle 7 is 110, And for the same reason, angles 7 and 5 are supplementary, as well as 5 and 6 are supplementary. So we have angle 5 is 70 degrees. Do we have everything yet? I think we've got everything but angle 10. Okay, so we've only got angle 10 yet to do, but we know angle 10 and angle 9 are vertical angles. Then we've got angle 10 is 70 degrees. So after all that, we actually have all of our answers. We can write them all in our answer sheet here for the guided practice. Let's go ahead and notate them all. So measure of angle 1 is 51 degrees. Measure of angle 2 is 59 degrees. Measure of angle 3 is 59 degrees. Measure of angle 4 is 70 degrees. Measure of angle 5 is 70 degrees. Measure of angle 6 is 110 degrees. Measure of angle 7 is 110 degrees. Measure of angle 8 is 70 degrees. Measure of angle 9 is 70 degrees. Measure of angle 10 is 70 degrees. Measure of angle 11 is 70 degrees. And the measure of angle 12 is 110 degrees. So these are the answers, and what I would suggest you do is take a look at this diagram, take a look at these answers, and try to figure out additional relationships that you can discover between the angles and the parallel lines and transversals that we didn't notice when we originally solved this problem. There are lots and lots of ways to solve the problem, lots and lots of relationships that we haven't even mentioned or explored.